Now, installing a program that you've downloaded from the internet is very common practice. And in some Linux environments, you can use package managers to automatically download and install your software for you. From the command line environment, you're not going to have that option, especially if you're logged on to a remote cluster, like the Palmetto cluster or other clusters. Typically, you're going to have to download and install programs yourself. And this is a very common procedure. These steps outline a very, very typical procedure for downloading and installing a program. The first step is to use wget to download the source file when you have a URL. Then you'll open up that tar.gz file. You'll move into the program directory, the source code directory, and then you'll do this very common three-step procedure. You'll do a configure, make, install. It's a very common procedure, but one unique part of this that I really want to make clear to you, if you're installing your own software and you want to do it in your home directory, if you're using a shared cluster and you don't have permissions to install programs in the user and opt directories, then you have to install programs in your home directory. And to do that with a configure script, you just need to specify, and this is the most common way to do it, is with this prefix option, and then specify the full path to where you want your program installed. Now I'm going to walk through this process. I'm going to download and install a program. Well, actually, I've got a program here in the intro Linux directory that I'll install. I'll install R. R is a statistical computing package. Now this is the tar.gz file that I downloaded. That's exactly what it will look like if you downloaded it from the internet. And so I'm going to skip the wget part, and I'm going to jump right into the tar-zxf. This tar-zxf, earlier I was showing the separate steps ofgunzip and then expanding the tar file. ZXF just does all of that together in a single command. So that's how I open my .tar.gz file. There are a lot of files contained in this directory, so it might take a few moments. Okay, now it's finished. The next thing I'm going to do is move into that directory and list the contents. So I see that there's a README file, and I see that there's an install file. I'll go to the install file to see what's there. Ah, this is great. This is what, now notice in these instructions it says to install it in Unix. For the vast majority of programs, installing in Unix and Linux follows the exact same procedures. So it looks like, yep, this is what I'm looking for. It's the instructions for installing it, how to compile it. Just like it says in this script, it says I'm going to configure, and then I'm going to make. You can optionally check the integrity of what you've built using make check. You can do some other things here with the make command. But finally, you'll do a make install, which takes the built compiled code and installs it in its final destination. All right, so I'm going to start that process. I'm going to run configure. I'm going to specify a prefix. And I'm just going to install it right here in the same directory where I'm currently working. And I'll call the directory R installation. And that starts the configure process, which can take a few moments. It's going to examine my system to make sure I've got everything that's needed to install this program. It's checking compilers and it's checking libraries and doing all kinds of things like that. Okay, it finished. it gave me a warning, and this warning looks like it's about a font that's missing, and that's not really important for this package, so I'm just going to ignore that warning. And that's fairly typical to get warnings. Warnings, read the warning and see what it says, but quite often you can disregard warnings. That's a very dangerous thing for me to say, but generally it's true. You can often ignore warnings. The next step, I just did the configure. The next step is to run make. Make will make use of a special file that's in this directory called the make file. The make file contains instructions on how to compile this package. So when I run make, it will start the compiling process. And this can also take some time. All right, it looks like the make process finished. And now the final step is to run make install, which will take the compiled executables and libraries and everything else that came with the installation and put it in its final destination. And it's that destination that I specified with the prefix. So everything's being copied over. This is usually the fastest process, the fastest part of the install process. And that's it. It's all done. Now my new program is installed. I'm going to cd up, and there's my new R installation directory. And it's created a bin directory where my binary executables will be stored. There's a lib directory where all the libraries are, and then a share directory for man pages and other things that come with the installation. And that's it. The installation is done. All right, some final things, some final, I guess, didn't really know how to categorize these other things, so I just wanted to add them here at the end. The top command can list all processes running on your machine. So if you're not sure if something is running in the background, you can always run top to see if it is. And now I'm logged into the user node of Palmetto, so I see processes that belong to other users. But what you'll see for the most part is a lot of processes that belong to root. Root is the administrator account for any Linux system. It's the most powerful account. And typically to install software and things of that nature, you need to have root privileges, unless you're doing something just within your own home directory. So you'll always see processes that belong to root, but in addition to that, you'll see processes that belong to you. And so what I'm looking at is it's updated every 2 seconds, and it's giving me an overview of the processes that are running, and you can see them sorted by percent CPU utilization. And then you just type the letter Q to get out of the top interface. And now I'm back to my command prompt. A couple of other things. You saw me use the Q, the letter Q, just to get out of the more and less and top and some other things. If you've got something running on the command prompt and you want it to stop, you can usually type Control-C, which is a break. It'll issue a program execution break and stop whatever's running. If you edit any files in a Windows environment and you try to use them in the Linux environment and they don't seem to work properly, it might be because there are hidden control characters embedded in those files. That's something that happens when you save a file with Windows, with Microsoft Word or WordPad and other Windows products. And there's a utility on most Linux systems called DOS2 Unix. And you can use DOS2 Unix to reconvert text files back to being pure ASCII files. That's ASCII files. And that's just a plain text file with no hidden characters. I mentioned tab completion, where you use the tab button to finish a statement or finish a file name or something like that. And the difference between a full path and other shortcut paths. Finally, this is related to file permissions. You can, instead of using change mod to change permissions of a file, you can actually change the complete ownership of a file or directory using the change own command. And then you specify the user ID and the name of the file or directory you want to change the ownership of. You can also change the group ownership in a similar way with the change group command. And then finally, to close your shell, to close your terminal window, or end your session, your bash shell session, you can just type exit or type Control D to close your shell. And one last tip that I want to tell you, that what did not appear in the slides, and that is the time command. If you're running a process that will run for some period of time and you want to know exactly how long it takes to run it, instead of using a stopwatch in your hand or something like that, there's a built-in command on the command line called time, and you precede time, you precede any command you want to use with time, and at the end of that command's execution, you'll get some output of how long it took to run that program. So I'm going to run that little loop bash script and time it. Let's see how long it takes. So this process takes about 10 seconds to run. And then at the end, you see these 3 lines. These 3 lines are produced by the time command. And the most important one is the first one. And that's how long it took for your process to run. And that includes any data transfer or CPU utilization or whatever. That's the overall time it took, the real time. That's the overall time it took in seconds for your process or program to run. And that's all. That's the really quick, lightning fast introduction to Linux on the command line. I hope this is useful to you, and I hope you return for the Palmetto training that follows this.